Hello there, welcome to session 5 of Unit 1, and in this section, we'll be looking at the concept of forces and masses. Let's look at the objective of this session. At the end of this session, you should be able to explain the nature and concept of force, list the various types of force, explain the concept of mass and inertia, and lastly, state the differences between mass and weight. Let's talk about the nature and concept of forces. We've all applied force one way or the other in our everyday life. We've helped someone to push something, we've helped a friend to carry something, we've helped our parents to also do some choices. So one way or the other, we've all used force. Newton studied this concept of force and stated that forces are what cause any change in velocity of an object. Thus, it is not possible to describe force as we describe material objects. We can only say what forces can do, right? If an object moves from a uniform motion, that's at a constant velocity, no forces is required for motion to the maintained displacement. The net force is the vector sum of all forces acting on an object. If the net force acting on an object is 0, then acceleration of the object is also 0, and its velocity remains constant. This means either the force is at rest or it will continue to move at constant velocity. There are two types of forces, and they are contact forces and field forces or non-contact forces. And when you say a contact force involves a direction of physical contact between the objects. An example of a contact forces we can say is a frictional force, where there's a direct contact between, say we are pushing something or dragging something on the floor, where there's a direct contact between what we are dragging, say the object on the floor, and the floor. Let's talk about also tension, where there's also a contact force as shown in the figure here, where we have two or a strange rods being pulled apart. Let's talk about non-contact force, so a field force. A field force do not involve any physical contact between the objects, but rather they act through empty spaces. And a common example is a gravitational force and an electrostatic force. Mass and weight. We've all heard of mass and weight in our high schools. What is a mass? A mass actually depends upon the amount of substance in an object. Likewise, weight refers to the gravitational force exerted on the object. So we've all checked our mass in our hospitals, right? Someone can weigh 70 kilograms, someone can weigh 40 kilograms, a baby can weigh say 20 kilograms. But when we talk about the weight, we want the person's weight with respect to the planet that the person is on. So when the person is on Earth, the person can weigh say 686 newtons, but when the person is outer space, the person can weigh 0 newtons. So anytime we are calculating weight, we calculate weight with respect to the acceleration due to gravity, so that you can multiply the mass times the acceleration due to gravity, and we know that the acceleration due to gravity is 9.8 meter per second squared. But when you move outer a space, let's say we are on a mass as in a planet Mars, the acceleration due to gravity on a planet Mars will be different from the acceleration due to gravity on the planet Earth. So the weight will be different. But when you want to check your mass and you weigh 70 grams on Earth, you go outer space or you go to a planet Mars, you are still going to get a mass of 70 kilograms.